My name is G, it's Josh and Alex. We're all at RedHat. And today we're going to be talking about Thermostat, which is we'll go into that, but the main focus will be new features in Thermostat. So we have a bunch of demos prepared for you guys, which should be pretty exciting. So first we'll start with the agenda. In the beginning, we'll give a little bit of overview on what Thermostat is for those who don't know. And then moving straight on, we'll start into the demos. So first we have Thermostat in Docker. Next we'll have plugin development, and then Thermostat and Byteman. And finally we'll close off with talks about development and the community and open source. So what is Thermostat? Simplest way to describe Thermostat is an instrumentation tool for hotspot JVM. So basically, whenever you have JVM applications or Java applications running, Thermostat is there to monitor those applications. And it'll give you information on them, such as CPU usage, memory. It'll let you see how long garbage collections take. It'll let you take heap dumps and analyze them, and much, much more. So along with Thermostat overview, we have the components of Thermostat, and so basically how Thermostat works. So Thermostat consists of three major components: the agent, storage, and client. So starting off with the agent, Thermostat agent is basically the monitoring device. So when you have an agent running on a machine, it's going to be the one that monitors all the Java applications and then sends that data to the storage. So the storage is where all the data is kept. At the moment, Thermostat supports MongoDB as the backend, and there is potential for switching to other things like SQL and whatnot, but the code isn't there yet. Another thing to note about the storage is that it accepts both direct connections and connections through an HTTP instance. So the MongoDB backend, you can run agent directly connected to the MongoDB, and it'll use the MongoDB Java driver to send information to and from. Or you can also run a web layer, the Thermostat web layer, on top of the MongoDB backend, and have users such as the agent or the client access that instead. And this gives you a little extra layer of security and opens up options for HTTP access. Finally, we have the clients, which is generally the most interesting part, since it shows basically all the data. And the Thermostat at the moment offers a GUI client, a graphical user interface, and a CLI command line interface client. And along with the client and the agent, we also have a command channel. And this is basically a connection between clients and agents that allow the client to request things from the agent. So this would be things like, in Thermostat, we allow you to perform complete garbage collections on any JVM that's being monitored. We allow you to perform heap dumps on any JVM that's being monitored. We also allow, if you have the correct permissions, to kill any JVM that's being monitored. And so all of that stuff will go through the command channel rather than through the storage. So while we're here, the best way to get a good idea of what Thermostat is to see Thermostat running. So we'll have a quick demo. So off to the terminal. So this is a Thermostat repository, and I'm going to go and run it. So, as I said before, Thermostat has a few components, but before you ever run Thermostat, you need to set up all the credentials and things like that. So, for example, when the agent connects to the storage, there's a username and password for that. When the client connects to the storage, there's also a username and password for that. And we do have a pretty extensive credential and access control system, but for the purposes of the demo, I'm going to keep it quick and easy. So we do have a setup command that lets you set everything up on your local machine. So once we've done that, we can start the web storage. And so what this is going to give us is both the MongoDB backend as well as an HTTP layer on top of that. And so once this is running, agents and clients can access it. So the next step would be to start the agent. So I'm going to just give it the defaults. And this is as I said before, this is what's monitoring all of your Java applications and sending that information to the storage. And finally, we're going to look at everything that's happened through the GUI user interface, or graphical user interface, sorry. And from there, Thermostat is up, and we can see on the sidebar we have JVMs, we have the host machine, information about that. As you can see, I'm running IntelliJ on the side, so you can see CPU information, garbage collection. Over here, there's a button to perform garbage collection, do heap dumps, there's Python stuff that Alex is going to go into later. Threads, you can see live threads. Should also be able to profile the threads. So I'm going to start that. You can see every single thread that's currently running and the state it's in over time. It's pretty cool. A new feature is the stack trace profiler, so we can see stack trace of the entire process and what it's running and how it's running, and a bunch of other things. So that's Thermostat in a nutshell. Yeah. One thing to note is that at the moment, what I just showed you, I ran the web storage, the agent, and the GUI. We also provide some easy commands to hook things together. So web storage runs web storage plus, the storage plus the web layer. And then we have web storage service. It runs web storage and the web layer, as well as the agent on your local machine. And then we also have an even quicker command from the set local. And I'm going to close everything I just started before. If you run this, it's going to basically run everything for you, all connected. So it's much easier now to get started with Thermostat, to have yourself looking at JVMs that are on your machine. The key thing to note about Thermostat compared to other Java profilers is that all of our systems, the agent, client, and storage, are designed to work in distributed environments. So what that means is if you have multiple machines, you can set it up so that you have agents on some machines, which are monitoring all the applications running there. And then you have, say, a storage on another machine with the web layer, where the agents will be sending to that machine. And then finally, if you need client access, you can access the web layer through any machine whatsoever. So it's pretty powerful in that regard. So moving back to the slides. The next topic is Thermostat and Docker, which I'm also going to be doing. I guess we could have ordered this differently. So Docker, we've had some presentations earlier today on containers, on OpenShift and whatnot, which all dealt with Docker. And today we also have another one, which is dealing with Thermostat and Docker. So a quick overview of Docker itself. It's basically a tool to support Docker containers, and those containers are software containers, which are basically isolated user space instances. So for layman's terms, they're basically super lightweight VMs that run on your machine through the Docker system. And the great advantage of that is that if you have a Docker container that you build on your machine, and then you give it to someone else who runs Docker and runs that container, it's going to run without any issues, which is cool. So Thermostat of Docker, basically we have, as I said before, the components, storage, and agent, and we've deployed those components into Docker containers. So there's a storage container and an agent container. And the caveat to all this is that if you have containers that are running Java applications, normally those applications are isolated due to the container system. But with a little configuration, you can also have Thermostats, containerized agent, monitor those other Java applications. So to go into a little more detail, web storage is pretty simple. It runs the web storage in a container. I'll show you that later. And then the agent container, which is a little more complicated, it runs the agent, but there are some requirements for the other applications to be monitored. And I'll go into that during the demo, which is now. So in the Docker demo that I've created, there's the agent Docker and the storage Docker, and I'll just give a quick run through of the Docker files that are there. So the first would be the storage one. At the beginning, we have our license, ignore that. It's GPL, if anyone cares, with class path exception. So it's a from Fedora container. So basically it takes the Fedora-based container and builds on top of that. We add some labels to make it easily identifiable, and then it basically installs Thermostat in the container. So the DNF install up here with the Mercurial, Maven, etc. are the dependencies for building Thermostat. It sets the environment variables required for the storage. So the port that the storage is listening on will be 8999. And then it runs, as you see, HD clone, which clones the repository, and then it just builds it. So it's pretty simple. Then at the end, we set the run script to be run thermostat storage. And what this does is when the Docker container starts, it will run that script. So in that vein, let's take a look at the script. And it sets a bunch of required configuration options. Disclaimer, this is all work in progress and the latest stuff, so it's subject to change, but it is working at the moment, which is cool. And at the very end, you'll see that it runs thermostat home / bin / thermostat web storage, which is basically what you saw me run on my local machine a few minutes ago. So all it's really doing is running web storage in a container, and then allowing people to access that through the Docker's network interface URLs or IP address support. So the next one would be the agent Docker. And if we just take a quick look through the Docker file, you'll see that it's pretty much the same thing. Oh, here it says also the requirements for other containers. I'll go into that after. But it basically runs the same thing with the configuration required for the agent, and then it has a script that's run thermostat agent. So if you look at that script, you'll see that it does set up all the credentials and whatnot, and then it just runs agent. So this is also pretty simple as well, compared to what I was just doing on my local machine. Going back to that Docker file, the key points about monitoring other applications that are also in containers, that they're generally not exposed to the outside environment. And that's pretty on purpose, I would say. This is the whole point of the containers, is that they're in their own system. But that makes it a little difficult when you want to monitor it yourself, because they're isolated. So the requirements for Thermostat to monitor another application in a container is that that container needs to expose the temp folder so we can access HS-perf data. It also needs to mount the thermostat agent image, and this is so that the thermostat agent can load jars for profiling. And then finally, it needs to share the host's network and PID space. And this is so thermostat agent can actually see this container running. So now that we've gone through all that, let's run it. I have some scripts that do that for us. Let's look through them quickly. So the run agent Docker is going to run our agent, creates a container with the name. It also needs to connect to the storage. So this storage IP basically figures out what the IP address of the storage container is and sets the connection to it. And then it has a bunch of variables here. And note here that in the Docker run, it must be privileged. It must have the host PID and net work stack. And it must also load the volume /docker/tech. So these are requirements so that the agent can view other JVMs. go to the storage one, it's pretty similar, has credentials for connections, and it just runs the container. So we can run the storage one. Hopefully I've set this up properly. And yeah, so the storage just started. The output is pretty similar to the local machine, except this is in a container. So if I open the tab and look at Docker. Disclaimer, I've set Docker to not need root, but please, if you ever use Docker yourself, do not make this setting. There's articles online explaining why this is really bad. To sum it up, if you allow Docker to be used by a user without root access, you are allowing root access for that user, based on how Docker works. The details are probably not really that important, but yeah, so don't run Docker as a user pretending to be root, because it's bad. But for this demo, since I don't want to type sudo all the time, I just did that. So you can see here with Docker PS, the storage container is running, it's port 8999. And if we inspect it, we can see down here that its IP address is 172.17.02. So if I were to take a browser, let's see where it goes, and try to connect to it, then it shows the authentication requirements. So the thermostat storage is up and running, and it's in the container. So next we can run the agent. So same thing, script. So since the agent needs the host network and PID stack, it does require root access, which is why it asked me for that. But now we have the agent running in a container as well. And so if we run the tab and check it out, yes. We have both the agent and web storage containers running, with the agent connected to the web storage container. So in that regard, we can now open a GUI client, and we should be able to see the agent in storage. So let's run. It's going to say fail. Here, I'm going to set the storage URL to the 172 IP. 172.17.0.2. And then, I didn't really point this out before, but in my script, I set the password and username to the client. So I wrote that correctly. Oh, it's not. Client, it successfully connects. And you can see here we have the thermostat agent Docker and its command channel running. And one thing to note is that because this agent is running in a container, it does not monitor any applications that are running on the local machine. So if you see here, this agent only sees itself at the moment because I haven't started any other containers. But if you compare that to my previous example, when I ran the agent on this machine, it was able to see all the applications like IntelliJ and whatnot. So in this case, it doesn't see them. But the purpose of this agent container is to look at other containers, not at the local machine. So if you wanted to see the local machine stuff, you would just run the agent on the local machine. So moving on, I can also start a small Java application that I wrote for the purposes, or that was written for the purposes of this demo. It's a simple Hello World web server. So if we treat it, increase the size, you can see that it contains a single Java file. And if we just read that, it really just responds to a GET request with Hello World. So it's pretty simple. And we're going to run that in a container using this new file I wrote. It's basically running the application in a container. and it's starting. And so now that we have a JVM in a container, we note that in these arguments up here, it's also using --PID host, --net host, volumes from the agent, as I said before, and then the Docker temp file being exposed. So these are all the requirements for any container to be monitored by the agent. So if we go to our GUI, the Hello World app has showed up. So with all these Docker files and changes, we are now able to monitor other JVM applications that are running in containers themselves. And that's about it for this demo. So back to the slides. Next session will be a plugin development by Josh.
All right, so as G said, I'm going to be talking to you guys a little bit about plugin development for Thermostat. And the idea is that you can extend Thermostat to do just about anything you want it to through our plugin API. You can extend the agent, you can extend storage, and you can extend the client to represent any data you want. So, as I said, customizing the agent or client to collect, record, and analyze your own metrics, and you can integrate your own tools into Thermostat. And we'll see an example of how you can do that. So most of the built-in functionality in Thermostat are implemented as plugins. If you go back to the GUI and you look at all those tabs, every single one of those is a plugin. And we load them using a framework called OSGI. And what OSGI is it's basically a modularization framework. It splits your code into sets of bundles, which export a set of services and a set of packages. And once you've registered your bundle on the framework, any other bundle that's registered can see the exported packages and services. So it makes your code very modular, it makes it really easy to test, and it makes it really easy to extend as well. So before we jump right into developing a plugin, we need to talk a little bit about the structure of Thermostat. So they're typically organized into several modules, and each of these is an OSGI bundle. So if you open up any of the folders in the source, you'll see stuff like client CLI, client GUI, agent, common. And these are all bundles, and they all extend different things. So let's just have a look at the source. So for example, let's take the dependency tool command. You'll see a command module and a distribution. Distribution is where all your compiled classes and jars go, and it also has this Thermostat plugin XML, which we'll talk about. And you see this command module right here. And if we look at this, and we look in the POM. So Thermostat's a Maven project, so we build it using these POM.xmls. If you ever have any doubts about the build or you want to see what's happening with the build, you can just look in these POMs and see the instructions being given. So right here is where we build the bundle. We use the Maven bundle plugin, and you can see the name of the bundle, the vendor, and what packages it exports and which ones are private. Is that visible to everyone in the back?
Well, maybe a bit bigger.
I don't know how to do it quickly.
Okay. For those who can't see, it's basically just a set of like XML-like tags. So for example, we have the bundle symbolic name tag. Inside of there is the name of your bundle. There's a bundle vendor tag. That's the vendor. And this export package and private package as well. And that just tells you which packages this bundle is exporting, which ones are private. So plugins should usually start with an idea of what you want it to do. So let's say you have some Java program that's doing a lot of communication on, say, TCP sockets and ports, and you're concerned that maybe there's some congestion going on. What you could do is write a Thermostat plugin to monitor incoming TCP connections and packets, and then you can display how many are being received at a certain address. And that's what we've done here with our plugin. First though, before we go into that, there's one thing you can do to make getting started with development a lot easier, and that is Maven archetypes. And I will demo that right now. Yes. Okay. So we're just in our basic Thermostat repository here. If you ls, you can see all the modules that you saw in IntelliJ. And now you want to run this one command, Maven archetype generate. It'll just build a few things first. Okay, hang on a sec. This is annoying. Maven doesn't automatically delete things. If the module is trying to find that it's actually there. So we can run name and archetype generate, and this will generate the whole project structure for us once it finishes building. So you'll see it'll prompt you for the number, and we provide two archetypes of thermostat. There's a single module and a multi-module. We're interested in the multi-module right now, so we'll run that. That is this number. And it'll ask you for a few things, group ID, so let's just do that. Artifact ID is the name of your plugin. It'll ask you for a version and a package name that you want to use. You say yes, and it'll generate that for you. And then when we go back to IntelliJ and look at the structure, we'll find our plugin right up here. And that's generated an agent, a client CLI, a distribution, and a storage comment for us. So we don't need to worry about the directory structure or columns or anything like that. It's all been generated for us. So going back to our TCP plugin, let's have a look at some code. And we can see just how you extend these various components. So it's down here. You'll see I've got an agent. So this is going to gather the data from the system with our packets, and it's going to put that into storage. There's a command, which is the command we made. There's some GUI code, so we've added a tab to the GUI, which you'll see. And there's comment. And in here, you'll find the way we interface with storage, and that's a DAO. A DAO is a data access object. It's basically what we use to query storage and to add items to it. So let's look at the agent. It's fairly simple, but we need to zoom in so we can actually see. For some reason I can't see that. There we go. Okay. So there's a little bit of code in here, but the main things you want to pay attention to are right here, this extend space backend. What that does is that when Thermostat starts the agent, it'll look for any classes that extend that, and it'll register that as a backend, and it'll make sure it runs that once it sees this bundle. We've got our DAO here, which interfaces with storage. And basically what we do is we have a 1 second timer, and every second it checks a file that we're outputting the packet information to and reads that, stores that in storage. So that's our agent extension. And we go to the POM. If we go to the POM, you'll see that we're building this as a bundle with the name staff agent. And we have a private package, we're exporting a package. So we have our data being gathered, so how do we store it in storage? We do that with our DAO. And the implementation is down here. And basically, when this gets activated, we register our queries to the database so it knows what to do with them. And then we basically have two main queries here. We have an add, which adds items to storage, and we have a query count, which will basically just tell you how many items are registered under this key. The slightly more interesting code is in our GUI, which is here. We're interested in the controller. Thermostat, for its GUI code, uses the model view controller pattern, and what that does is it just separates out your program logic from your UI code. All of your UI code goes into the view, and all of your program logic gets separated out into the controller and the model. So when we construct this, we grab our DAO from the framework, and then we set a timer, and every so often we'll update the data in the graph. And our panel, which is what gets added to the GUI, is basically just a basic header panel. So you'll have a title at the top, and it's got a graph. So let's run this and have a look. That's yours. Okay, I've already got this open to the bin. Keep it zoom in. Yeah, local. So we're just going to run thermostat locally to get things going quickly. It runs everything for us, as G said. Yeah.
So just an explanation of what happens. My Docker demo is still running, so the command channel, which is trying to bind to an IP import, can't because the for facility use.
Unique to Kang from Seneca. So let's. Oh, is this still wrong number? So if you go here and you view all the agents, you'll see that our agent is running right here. It's the system tab backend. And if GUI wants to cooperate, you can see it. Doesn't want to cooperate right now. Not sure why. Okay. The main thing to take away from this is that Thermostat is extremely customizable, and if you got any of the tools you want to use, you can easily integrate them with Thermostat. For example, here, I've done some integration between SystemTap and Thermostat. XSystemTap script running in the background that gathers data from TCP packets that are being received, outputs that to a file which Thermostat can then read, and it represents the data for you all in the same tool.
Let's try.
Yeah, we're having some demo luck. We're having some demo luck right now. There we go. Okay. So our agent is running, and you'll see this new tab here, System tab. And if you look at that, it's got a nice graph. And this is displaying the number of packets it's receiving at this address support. And you can see that steadily going up. This address support happens to be the one we use for communicating with storage with Thermostat. So you can see all the communication that's going on between storage and everything else that's connecting to it. So that's basically plugin development. We've got a lot of great resources on our wiki website that they can have a look at if you're interested. And up next with an example of a more complex plugin, and also a really cool one, is Alex talking about ByteMan.
Thank you, Josh. All right, so I'm going to be talking about a plugin that's currently under development for the next Thermostat release, hopefully, and that is going to be the ByteMan plugin. But what is ByteMan before I go into what the plugin actually does? Well, ByteMan is a tool for monitoring, debugging, and testing Java code. And it does this using the Java JVM tool interface agent. It allows it to extract more intricate details from the JVM. And what you can do is you can install this agent through the command line and inject DSL-specific code into the JVM to monitor what's going on within your Java program at a more intimate level. So we're able to inject and trace code in the JVM, either at JVM startup, or you can inject a rule into the JVM when the application is already running. This injected code has access to all application methods, public or private or otherwise, and these rules can be unloaded and re-injected at will. So the rules have a basic syntax that looks something like you see before you. It kind of represents the basic Java syntax. So we have a unique name for the rule because the rules get loaded and unloaded by rule name. We have a class, which is going to be the class that you're looking to monitor. You can specify method names, so say for instance, when this method gets hit, do something. Then we have an at keyword, so for entry or exit. So say if you want to monitor what happens when you enter a specific method versus what happens when you exit a specific method. We also have an if statement. You can add a condition to add a bit more robustness to your ByteMan rules, to give it a bit more logic. And the do is the action that actually gets performed by the ByteMan rule. And I'm going to give you a quick demo on how ByteMan actually works. All right, so use a different keyboard layout. There we go. Okay, so for today, I've prepared a really basic demo using Hello World. So if I type in Hello World here, we can see on the screen that it printed Hello World. But I've also written a more complex version. Well, I wrote a rule that we can use to monitor what happens to this specific Hello World when it's running. Just to show that there's no magic going on, this is what Hello World looks like. But we're going to inject a rule into this to see what's going on. So if I type in Java and then use the Java agent argument to supply byteman home. So byteman can be supplied as a jar. So we're going to point to that, and then we're going to use the script flag to import this rule that I've written. And then we're going to run the program as we had before. And that wasn't supposed to happen. Alas, it works. Right. So this time when I ran the program, something different happened. Not only did it just say hello world, but all your base are belong to us. So let's take a look at what actually happened here. We're going to take a look at the byteman rule that I've written, just to give a basic introduction to what the syntax is like. So here's my basic rule. It's called example rule. And when it hits the class hello world main method, when it enters, it is true. So it's going to do the action trace line, all your cases belong to us. And here, the action trace line is actually an alias for a system.out.println. So it's able to basically print that line before any of the code runs within the main method. So that's kind of like a really simple example, how you can use byteman rules to trigger different events when you're running your code. But we feel like this is a very powerful tool, and it's very good to have within Thermostat when you're wanting to debug your different types of Java programs. So what Thermostat does is automatically installs the agent. We have a graphical user interface for injecting and unloading rules, as well as for visualizing your metrics. So we have it returns back in JSON format metrics, so you can get a more intricate rundown of what's actually happening, as well as we have a little graphs tab that you can use to visualize the data as it's coming in. So today I prepared a very simple example just to demonstrate how you can use this to look at different classes. So I prepared a little application based on the consumers and producers problem. For those of you who don't know, it's a pretty basic example used to show how different processes communicate with each other. So we're going to have a bunch of producers that are going to be generating and placing items into a fixed size queue that's shared between producers and consumers. And the consumers, when available, are going to be taking items out of the queue. So the problem here is the consumers can't type something if there's nothing in the queue, so it has to wait. So here's a basic rundown of the code that's going on here. So when the producer is available to add items to the queue because it's not full, we'll do so, and likewise the consumer will take things out when available. So I wrote up a quick byteman rule to count the number of times each of the actions are being performed. So it's pretty much like the last byteman rule that I showed, except it uses this button keyword. And you can use it to declare variables that are going to be incremented by another byteman rule that I've written. And the action here, do send, will send the metrics back to Thermostat so we can see what's actually going on. So it'll have the marker producer, it'll say that we hit the add item method, and then the current times that we've hit that method. And here's a rule that basically just increments the counter that I had just declared. And I'm going to show you how this works. So I have this package as a jar, my demo. So around the side here. Let's get out and run some Thermostat. Right. Great. And then you have. And we're going to run Thermostat local at RMRT first. And just wait for Thermostat to come up. Great. So you can see that my jar is recognized here on the left-hand side. So I'm going to move over to the Byteman plugin. And here we have a graphical user interface for injecting and uninjecting rules. So on the left-hand side is I'm going to put in a rule that pertains specifically to this program. And then I'm going to load it in, and we're going to see what happens. All right. So I have my rules on the left-hand side here, and I click button over, and you can see that the rules have been injected. I don't know if you saw in the background, but the terminal actually moved a bit. It just gives confirmation that the rules have been installed. So we're going to go over to the metrics tab, and I'm going to run my program. So I have two different sets here. Basically, the program is going to terminate once the consumer has taken 15 items out of the queue. And in one instance, the producers and consumers will be looking and taking items out at a very constant rate, whereas the other one, the consumer, is very hasty. It really wants those items. It's going to be looking at it really faster. So if we run the balanced version here, you can see the metrics pulling in through the metrics tab. It'll say have the different numbers pertaining to how many times these methods are being called. And we can see that the program finished. All right, so in an equal balance, the whole program took about 7.77 seconds. And if we're here to look here, we can confirm that the consumer has indeed taken 15 items out of the queue. And a whole bunch of different metrics related to how many times they slept, or were waiting to look at the items, or were producing items if you're the producer. So let's take a look at the other one, and then we can compare something else. So what I just did was I just uninjected those rules because I'm going to be installing new rules for a fresh slate. All right, I'm going to inject those. Let's see what happens now. So we're going to rerun the program, but this time the consumers are looking at a lot faster rate. And after 15 items were taken out, this run took 7.11 seconds. But what's interesting to note here is that the consumer actually waited 47 times. So in the last example, they were taking out at a fairly even rate, so I think the consumer must have taken, so the consumer waited about 15 times. But in this instance, it took a lot more. And we can use the graph tab here to kind of visualize what was going on. So the first two here are the ones that I just ran. So this is consumer. It had a lot more calls. But in the other example where they're more even, they were more localized and more evenly distributed. So this can be a very useful example of how to kind of probe and figure out what's going on within your code when you're not quite sure what's going on. Because say, for instance, if you look at these two things, they both did the same thing, but they took a different amount of time. And if you're not knowing how to go in and actually trigger these different events to see what's going on, you might not be able to figure out what your problem actually is. All right, so as I said before, this plugin isn't currently available in the release that we had just done in July. This is potentially slated for our next release, which would be Thermostat 2.0. Things that we're going to be working on in the meantime is improving the workflow here and just making sure the GUI looks nice and sharp, and better agent rule management. So if you thought Byteman was cool, go check it out. I highly recommend it. It's a really neat little tool, and come check it out in Thermostat as well. I just briefly want to touch on the development and the community that we have surrounding Thermostat. So if you ever want to get Thermostat started on your machine, it's very simple. If you're running Fedora, you can just DNF install Thermostat, or if you're using an older version of Fedora, you can run yum install Thermostat, and this will get you our latest stable release, which will be 1.6. But if you want something more cutting edge, come visit our website and download the newest stuff that we're working on. We use OpenJDK 1.7 or above. We use MongoDB. For our version control, we use Mercurial, and all of our projects are built within Maven. And we have this different development methodology where all of the stuff that we're currently working on go into the latest branch. So this is Thermostat 2.0, and everything that we're currently working on goes there. And then once it's time for a release, we backport all of our things that we just made sure that the API is very stable, and then that's what gets released. So our latest release actually took place in July of this year. It was Thermostat 1.6, and that introduced the local command that you had just seen, as well as a number of different features, such as the find VM command that you can use to search for VMs through the command line, and our true map profile, which looks pretty cool. But we're looking forward to the future, what's the latest and greatest. So Thermostat 2.0, hopefully coming sometime in the near future. We're looking currently at the Byteman integration is going into there, as well as a whole bunch of other things such as data model refactoring and Windows support. Maybe it's getting there. And lastly, get in touch with us. If you think there's a plugin that you think would be really useful for people, come let us know. Our website, actually G was working on it fairly recently, it's looking nice and fresh. You can download all of our source on there, as well as a little guide on how to get involved with Thermostat. Come say hi, visit us on Freenode. We're on channel Thermostat. Join up for our mailing list. If you think you have found a bug or you have an idea for a plugin for us, just shoot us an email. We have a Bugzilla, so if you are interested in participating in this project, there's a whole bunch of different bugs that you can kind of check out and start getting used to and contributing patches to Thermostat. And with that, I'd like to thank you for being a good audience. Are there any
Are there
questions?
any comments or questions? My goodness.
Question at the back?
So I saw that you have thermostat monitoring regular job applications. Do you guys do monitoring on like, for example, say I have a bunch of web applications, and then can I run thermostat on each individual web server? And these web servers are making requests to each other. So there's like one request going here, another request going to another service, another request going there. Can you trace that whole transaction from like start to end? Or is this just one? I'm running it on one machine. And just
If you run the thermostat agent on each of those servers, then it will be able to monitor and get that data from all of the applications on those servers. In terms of tracing the calls themselves, you can profile each individual application and see what calls are being made. But in terms of connecting all of that data together, I would say Thermostat doesn't currently provide anything like that. Yeah. You can take the data and analyze it yourself, though, once you've got it from Thermostat agent. But yeah, if you want, you can create a plugin too.
right?
Any other questions? Yeah.
How intrusive are the agents?
Pardon?
How intrusive are the agents? Do they use
So by default, the agents only monitor a small subset of information, so it doesn't do the thread monitoring or the stack trace profiling by default. So those things you have to turn on themselves, because those are much more intrusive to the applications themselves. So I'd say it's very not visible when you just run it by default. But the information you get will be like the CPU, memory, heat data, the garbage collection, power stuff. But like for the more specific information, say you want to profile the method calls that are happening, you can start them. Like the user has to start that themselves, and then from that point, the agent becomes a lot more intrusive.